Alright, this section here is over rational exponents. If I have 36 raised to the half power and we wanted to simplify this, well, this is like saying, whoa, not a 3 but a 2 roots of 36 which is equal to 6. Okay, equal to 6. 6 squared is 36. Alright, let's look at another example. What if I had 121 and it was raised to the half power and we wanted to simplify this down? Well, I'm going to tell you this is going to be 11, because 11 times 11 equals 121. So hopefully you're catching on. If I had 196 and it was raised to the half power, so we're thinking that there are two numbers that when we multiply them together we get 196. And what could those two numbers be? X is 14. So 14 times 14 is 196. So this equals to 14. If I had a nickel for every time I did that, I'd have some money. Okay, 25 over 36. And this time it's all raised to the half power. So I'm not sure I mentioned this yet, but should have already mentioned this. Rational, right? When we talked about rational, we were talking about rational numbers. So a half is a rational number, and it happens to be up in its exponent, the exponent of this number here. Okay. We can actually break this up. This is 25 raised to the half over 36 to the half. Two numbers multiply together to give us 25. How about 5? Two numbers that multiply together to give us 36, and that would be 6, right? 6 times 6 is 36. Okay, so we look at this 2 right here. We think we need two numbers. All right. Okay. If I had 9 over 49 and it were raised to the half, so two numbers multiply together gives us 9. How about 3? Two numbers multiply together to give us 49, and how about 7? So this time I didn't break it up, we just kind of looked at it, alright, because we know that this is going to be 9 raised to the half and 49 raised to the half. So that reduces down to 3 7s. Man, we are moving along. What if I had this? I need two numbers to multiply together that gives us -1. And there are no two real numbers. Okay? So in this particular case, no real numbers, no solution, right? Or I should say it's not no solution, but I'm going to tell you that it's not a real number. This is not a real number. And I think in intermediate algebra we will get into complex numbers where we can actually find a number. But other than that, it's not a real number. And that is, it doesn't come from the set of real numbers. Alright. Let's look at something other than an exponent raised to the half power. What if we had 8 raised to the 1/3 power? So we're looking for a number that we multiply by itself 3 times that gives us 8. Well, you got it. It's 2. 2 times 2 is 4 times 2 is 8. So 8 raised to the 1/3 is equal to 2. What if I had threw a negative out in front of this? Well, we end up with the same thing, other than it's going to be a negative 2. A negative 2. Okay. But what if I had this? Now we notice that our negative is in parentheses here. So we're looking for a number that we can multiply together 3 times, and this time gives us negative 8. Well, if I were to throw a negative out front of all of this and said 2 times 2 times 2, that would be negative 8, right? That would be negative 8. So I can break this up into negative 1 raised to the 1/3 times 8 raised to the 1/3, which is not necessary to put that in parentheses, but negative 1 to the 1/3 is just negative 1, and 8 to the 1/3 is 2. So we end up with negative 2. See that? Negative 1 raised to the 1/3 is negative 1. That'd be negative 1 times negative 1 times negative 1 is negative 1. Okay? Alright. Let's clear the board on that. If I were to have 8 raised to the 2/3, well, what we want to do here is I'm going to go ahead and write this as 8 to the 1/3, and then I'm going to put all of this in parentheses and raise it to the 2. Now, exponents you multiply. Remember, you multiply exponents, so 1/3 times 2 is 2/3. But we've already solved the inside part of this. This is 2 squared, and 2 squared is 4, so this is all equal to 4. If I had, let's say we've got this 16 over 81, and it is all raised to the 3/4. Alright, so I'm going to rewrite this as 16 over 81. Okay, and it's going to be raised to the 1/4, and all of that will be cubed. So we're looking for a number that we multiply together 4 times, we get 16. Let's see, 2 times 2 times 2 times 2, so let's see here, 16 to the 4th, whoops, it's a 4 there, is 2, right, because 2 to the 4th is 16. And what about 81 to the 4th? Well, let's look at this. We know that 81 is 9 times 9, and each one of these is 3 times 3. So there are 4 numbers, and they're all the same, so that's going to be 3. So this is 2/3, and it's still raised to the 3rd. So 2 to the 3rd is 2 times 2 is 4 times 2 is 8 over 27. 3 to the 3rd power is 27. Alright, a few more here and then we'll work some with some variables involved. How about we have 25 to the 1/3 times 25 to the 1/6. So we want to reduce this down. You're going to be surprised. Alright, we got the basis is 25, so I'm going to rewrite that. And we can add the exponent, so that'd be 1/3 plus 1/6. Now, we got to do 1/3 plus 1/6. And I'll just do that right here. So you got to be up on your fractions now. So we got 2 plus 1 over 6, which is 3 over 6, which ends up being a half. So this is 25 to the half, and two numbers multiplied together gives us 25, and that would be 5. So all of that is equal to 5. Who would have known? Who would have known? Let's see. Well, you know what? I think we've got some x's involved now. We're going to do some variables. So we got x, and this is algebra class. And x to the half. So what I'm going to do is I'm going to go ahead, take this x up into the numerator, so it becomes a negative a half. So now we have x to the 5/3 minus a half. So we want to get that all into a single fraction, so we say, we'll just work it out right here. Right, we can do this cross multiplying thing. 2 times 5 is 10, minus 3 times 1 is 3, and 2 times 3 is 6, and that becomes 7/6. 7/6. So this equals 2x to the 7/6. Alright? What if I had 2x to the negative 2/3 over 3x to the 1/4? So this time the negative exponent's in the top. So I'm going to take the negative exponent down into the denominator. And we have x to the 4th times x to the 2/3 this time. So rewriting 2 over 3x, we add exponents, 1/4 plus 2/3. Right, let's just do that up here. 1/4 plus 2/3. Right, 3 times 1 is 3. And 4 times 2 is 8. And then we just multiply them together. You know, this is a shortcut. 8, 9, 10, 11. It looks like over 12. So this is going to be 2 over 3x raised to the 11/2. Right, proper fraction. As your exponent, yay. Okay. What else can I do? I don't know. -6, x to the 3rd, y to the negative a half, and that's over 4, x to the 3rd, and y squared. So this becomes, 2 goes into 6 and 2 goes into 4, right? Throw this negative up front. 2 goes into 6 3 times. 2 goes into 4 twice. I take this, this is x to the 3rd, x to the negative 1/3. I'm bringing that up into the numerator. And So we're going to have y squared, and we're going to take this y to the negative half down here to the denominator, so we have y to the half. So we're going to have negative 3 x, we have 3 minus 1/3 over 2y 2 plus a half. So we got 3 minus 1/3. Alright, writing a 3 over 3 here. 3 times 3 is 9, 9 minus 1. 3 times 3 is 9, and 9 minus 1 is 8. So this becomes 8/3, and then we're going to go ahead and, so I'm going to take it you might have forgotten. 2, you could also look at it this way. 2 times 2 is 4, and 4 plus 1 is 5 halves. Alright, faster way of doing that. So this guy, bringing this equal down here, negative 3 x to the 8/3 over y, whoops, we about forgot the 2 down here, y to the 5 halves. Moving right along. Let's see what I've got left here. Alright. I got some really nice ones. Negative 27 x to the negative 1 over 8 y to the negative 3 halves, and all of this is raised to the 2/3, and we want to simplify this down as much as we can. So we can distribute this exponent here across. I'm gonna, let's see, 9, 3, 2, okay, I don't see anything. That's not going to reduce down. Negative 2/7 raised to the 2/3 x, now we multiply exponents, that becomes negative 2/3 over 8 to the 2/3 times y. This is a negative here, so we have 2/3 times negative 3 halves, which leaves us with a negative 1. Yeah, so that's just going to be a negative 1. Alright, okay, this guy right here, this is, let's see, that's going to be 3 times 3 times 3 is 27. So that's going to end up being a negative 3, but then when we square it, we're going to get a 9. So 9y over, this is 2, 2 squared is 4, x to the 2/3. We've got to bring this back down into the denominator and bringing that up into the numerator. Alright, so hopefully I didn't work that too quick there. Okay, so all that reduced down to this guy right here. Alright, I'm going to write a couple problems out and you try to figure them out. Alright, so this is quiz time. We have 25 x cubed over 49 y to the negative a third, and it's all raised to the negative half. Alright, so that's one of your quiz problems, and then the other one is going to be xm raised to the half times xm raised to the half, and you want to simplify both of these down. So there's your quiz. Quiz problems, quiz time. So do it. Alright, pause the video, come back, and I'll work them out. Okay, so I'm going to go ahead and work these out now. This is to the negative a half. Okay, and you can flip this guy inside. We talked about this in a previous lesson, about the shortcut on that. So this becomes 25x to the third, and now it's all raised to the positive a half. Now we're going to distribute, so 49 raised to the half times y. We multiply exponents, so negative a third times a half is going to be negative 1/6 over 25 to the half, and 3 times a half is 3 halves, so x to the 3 halves. Alright, and of course this is 7 over, this is going to be 5 x to the 3 halves, and because it's a y to the negative 1/6, we're going to bring it down into the denominator. We want to write our answer with positive exponents, and so there you go. That should be the answer that you come up with. Now let's get the answer to this one. This should have been an easy one. Times x to the m over 2. So x to the m over 2 plus m over 2, and that's a half plus a half, which is 1. So we're just left with x to the m. So there should be your two answers. Alright, and I believe that's going to conclude this section on rational exponents.